Welcome everyone. Today's knowledge session has a topic of introduction to TitanDB. So this is the agenda for today's session. We will discuss what are the graph databases and actually why we need a graph database in the first place. Then there is a specific graph database that we are working on and exploring right now. So it is TitanDB. So we will see what are the benefits of TitanDB, why should we use TitanDB, and what is the cap theorem in TitanDB, and the architecture overview of TitanDB and the future of TitanDB, that the growth of the TitanDB that it is being developed. So other than that, there is a TinkerPop API given by Apache, which is being used in as the native API in TitanDB, and it is like we will discuss it in further slides, that why we should use TinkerPop and what are the advantages of TinkerPop. So, and later on we will have a demo that will show you the CRUD operations on TitanDB. So we will be using Cassandra data store with the Titan database, and we will be storing two vertices and one edge with some labels, and we will operate on them. Like we can update the labels and we can change the values. We can retrieve and query what are the labels, and we can also delete them from the data store. So what is a graph database? Basically, a graph database, as you may infer from the name itself, that it stores data in the graph form. So a graph is something that has nodes, edges, and properties. So as you can see in the depicted picture as well. So the graph has records that are stored as nodes. So nodes are the entities, and the relationships are stored as edges. So the relationships are between one and more nodes, and the properties have the properties are the key value pairs that we store within a node or on edge. So it actually stores the values that we want to share with the node or the edges. So most of the graph databases are NoSQL in nature. So they are schema free, and we can give them schema, but basically they are free flow. We can have heterogeneous data being stored in a graph. We can connect different vertices, and we can have a data store at the back end which stores the graph data in JSON format. So, but the graph database itself renders the data as vertices and edges on the console, and we can also use visualization tools with them. So we can paint a very typical graph on a browser or using JavaScript nowadays as well. So store data in a key value store or a document-oriented database as a backend source, and one peculiar property of a graph database is that it stores the relationships or the edges as the first class citizen of the database. So anything that you can do with a vertex, you can also do with the edge. Any property that you want to store on a vertex, you can also store on an edge. So most people are not very familiar with the notion of storing properties on edges, because they are usually always storing data regarding entities and not relationships, because RDBMS is like using relationships within the data itself. Like we have foreign keys for depicting the relationships between the entities. So but this is one of the advantages that graph database provides us, and we can use it, and it is very powerful because it gives us the direct data from the relationship itself. So we do not need to query, or we do not need to join multiple entities like we do in RDBMS.
So question, you said that it stores data in a key value store or document-oriented database. So that is what the graph DB is, right? Why do I need a Cassandra with that?
No, actually what Cassandra is, like Cassandra is the actual data store. where we are persisting the data. So graph database is actually just a middle layer. It's just a middle layer. It basically converts the graph that you are having in your application. So vertices and edges that you create in your graph are being stored as JSON or GraphSON within the data system.
So it always has to be backed up with a
yes. It always has to be. There is a compulsory requirement for having a storage backend. So we will see that Titan database is very flexible and provides us various features and various other backends that it can work with. But most popular nowadays is Cassandra, with which it is working.
So I think the question behind the question was that, do I need to have another data store or put it in the file system?
No. We need a data store.
Keys value can be anything, right?
Keys value can be anything.
Key and value can be anything.
Yeah, it's like whenever you find JSON, it's like compulsory for key to be a string, but value to be anything.
So like when we are storing a graph, like key, vertices and edges.
No, it's like you can say that in a graph, vertex is a entity and it contains a property. So yeah, the properties are depicted as key values. But when you convert that into a JSON, the whole vertex itself is an object. So that object gets converted into key value JSON format. So need for a graph database, as you can see from the picture, I'll come to the points later. So you can see from the picture that if we are having a relation database, so suppose there are adjacent relationships. Suppose Alice is having a relationship with 3 of the departments. So here we need to create a lookup table between the two, and we will store the keys for both, and we have to infer, or we have to look up indices, index them multiple times to find the data, and it will get you in serious troubles if there are multiple of adjacency that we define in graphs. So suppose there were in the above graph, the Alice is connected to 3 departments, and further on connected to 4, further on connected to, it can go exponentially. So in that case, if you are depicting that data in your RDBMS format, then you will need to create multiple lookup tables, or you will also be having a very heavy query to get the data. So in graph database, you can very easily traverse through the edges and get the required data without any extra lookup that you need to make, or you do not need to even make any other indices. The graph database contains basically Titan does. Most others will also do. I do not have that much experience with the graph databases, but most of them also have the basic indices done on the vertices and on the edges. So we can easily query them, and this is the major advantage that we get from graph databases, and it is totally dependent on the use case that you have. So it's not always good to use a graph database, but yes, the data can be represented in any of the databases, like relation databases or NoSQL databases can also represent the same data that you use to represent in graph database, but it is much more simpler and easy to query and use the graph databases with such kind of data. So it is basically used with highly connected components. Suppose you have data which is highly connected, like nowadays Facebook does have very highly connected data that you need to know your friends, then your friends of friends, and so on. So they are connected, and Facebook itself uses graph databases to render those. And most of all, the databases are even connected across the applications on the web, like Facebook and LinkedIn and other social media, using their own databases, connected in some sort. So it helps in all these scenarios. So it removes the need to perform multiple join operations between adjacent neighbors, as I already mentioned, and it also allows you to use many of the algorithms that we use in in OLAP, like in analysis purposes. So we can use the shortest path algorithms to get to some vertex from another source vertex. So we can use any of the algorithms that are mentioned in any of the mathematics books that we have already read. So it also allows you to visualize the data and infer relationships and make predictions. So you can forecast if you are having a OLAP system. So we already know that the OLAP contains the historical data. So in that case, what it does is like we can visualize the graph using like Linkurious and Jiffy. Jiffy is open source, but Linkurious is like a paid version. It does have a toolkit which is open source, but it does not support most of the recently used databases apart from Neo4j, because it is something that is being supported by most of the applications around the web. So it is the oldest one, like the most popular right now is Neo4j. But this database, the Titan database that we are going to discuss, is going to be a great competitor to Neo4j in future, because it provides many of the features that Neo4j does, but it is free and open source. So why TitanDB? So TitanDB is highly scalable and provides you facility to store large graphs, and it also provides you the asset properties, so you can use the transactions, and not just the transactions, it provides you a facility to use the transactions in multi-threaded environment as well. So like it is thread safe. All the transactions that Titan provides is thread safe, and eventually consistency is provided. So what eventually consistency means is like after a certain point of time, like you will always get the updated data. If there is no more hits, or if there are no more updates being performed on your data, then after a certain period of time, eventually you will get the consistent data. You will get the same data for every hit that you make. So support for many concurrent transactions, as we can include many machines on your cluster, and the database itself like supports the scaling of your graph across the machines in your cluster. So as you add a machine in your cluster, it automatically scales your graph to accommodate the machine and use it. So it's like more the number of machines, more the number of users that can use the same graph and can make concurrent transactions at the same time. So also it provides a way to use the complex traversal queries using indexes, and it gives a huge data set results in milliseconds as well. So one of the key features that TitanDB provides is the vertex-centric indices. So this is one of the features that is not present in Neo4j as of now. So but what vertex-centric indices means is like you have a huge graph, you have an index that is being defined on any of the particular vertex. But the thing is, if you are having an index in your graph, then that index will be defined for each and every vertex. So vertex-centric indices means you can provide a label, and you'll say that only this like any vertex that matches this label only index on those vertices, and not on all the vertices. Forgive me for my sore throat. So yeah. So like I was explaining what is vertex-centric indices. So in this is the feature that is not present in Neo4j as of now. So this is a key feature of TitanDB, and it is the value that this provides to solve the infamous supernode problem. So what is a supernode problem? So a supernode is something you can say a node or a vertex in the graph that is having a huge number of edges going through it, and whatever way or whatever path you choose to traverse, you always have to go through that vertex. So that vertex is like called supernode, and it's like very difficult for our queries to handle these vertices, and more the number of edges, it gets typically very hard to handle the queries, and most of the time it delays your results. And so vertex-centric indices provide you a way to counter that problem, and it's very helpful in many optimizations. So also the internal representation, how TitanDB stores graphs in your disk storage is very much to its own unique. Actually, what it does is like it compresses your edges. If you are having two vertices with some default IDs and you have an edge between them, so it will automatically determine the difference between the number of, you can say, differences between the IDs, and it stores those differences among the total representation with the like you can say, suppose there are two vertices with different IDs, but when you store them in the database, it becomes very huge. The number itself is in millions, because it can store billions of vertices. So as the number of vertices increases, the ID number itself also increases, because the ID is generated automatically by Titan. So what it does is like it creates the difference between the two IDs and stores with that, and it typically compresses the data that you are storing in Titan. But every time that you fetch that data, it decompresses it and uses it. So it's like almost gives you the same result, but it provides you a optimization on storage. So. And another advantage of it is like it is open source and having a Apache 2 license. So the features of TitanDB. So as I already mentioned that TitanDB supports many of the storage backends. So it can be used with HBase, Apache HBase, and Apache Cassandra. It can be used with Oracle BerkeleyDB. But the differences here, like we can discuss in CAP theorem as well. So I will keep it for the slides. And so it also supports the OLAP data analytics and graph operations using Apache Spark and Hadoop. And you can also use the full text search using Elasticsearch or Lucy. So it is also having a native integration with the Tinkerpop graph stack. So I will discuss in detail what is Tinkerpop and why it is being used in here.
So can you use Elasticsearch instead of Cassandra?
No, actually it is a index storage. So so there is a difference. Like I'll show you in the architecture. There is a difference between the backend storage and the index storage. So index storage is optional. You may not be using it if you do not want to have full text search in your application. You can omit it, but the backend storage is necessary. So the power that Titan gets is from the backend storage. The type of backend storage that you are using provides you a different kind of facility. So in Cassandra you can have high availability, and in your HBase you can have high consistency. So it's like I'll discuss in CAP theorem like from here. So in HBase you can have high consistency with the partitionability of the network, and from Cassandra you can have a high availability with the partitionability of the network. So it is the CAP theorem. So what is the CAP theorem? So CAP theorem states that among these three things, consistency, availability and partitionability, you cannot give all three things to a particular, you can say in here, database. So all three things will not be present, so only two of them will be present. So Oracle BerkeleyDB is the exception because it is not a distributed one, and actually it is only used for the testing purpose of Titan. So yeah, the HBase is like favors consistency in a way that it can say that your request may not be completed, but you will get the result. And Cassandra is like high availability. It's like you will always get the answer, but I'm not so sure that the answer will be like complete or not. So BuckleDB is not distributed and it is only used for testing purpose. So there is a trade-off between the HBase and the Cassandra. It's like it's on your use case, so you can decide with which you want to go with TitanDB. So TitanDB is just a middle layer, and data storage is where we are storing the graph.
How does it support to Cassandra storage backend? How does it support to Cassandra backend?
So there are configurations, and it basically does the mapping and all the schema in itself. Like you can define a schema in Titan, and mostly TitanDB can run with Cassandra in 3 different forms. You can use it on a local mode, you can use it in a cluster mode, you can also use it in an embedded mode. So if you are using embedded mode with Cassandra and Titan, then they are running in the same JVM, and the communication between the processes is like negligible. So there is no serialization of the JSON that they are sharing. So as soon as Titan gets the data, it can just put in the Cassandra storage, and there is no serialization. But if they are like on cluster or on local mode, that is if they are running on separate JVMs, then there will be serialization, and like there will be some delay or latency on the network.
So the ultimate storage is JSON.
Ultimate storage is yeah. So yes, you will say that. So the architecture of TitanDB is like the OLAP is supported by the graph computer. So a graph computer is a system that runs on every vertex of the graph. So it's like it uses the like it is very it provides you the scalability. It runs all the operations that you need to run in parallel according to the cluster that you have, the size of the cluster. So number of machines that you have in the cluster, they will all do the same thing on all the vertices in parallel. So and also OLAP is supported by Spark, Hadoop, and Jira, as I already mentioned. So here the storage backend is a must. This is compulsory part, but this external index backends which provides you searching indexes and full text search feature is like optional. So also there is a Tinkerpop API native in Titan. So Tinkerpop is you can say that it is an API that provides you generic methods that you can use with any of the graph databases to perform your graph traversals and perform your operations on any graph. So what is the actual use of Tinkerpop? Like it gives you loose coupling on the database that you are using. You can change your database at any time because you are totally compatible with Tinkerpop. So any database that you are using right now which is compatible with Tinkerpop, you can change it with another one.
So what are the databases which are compatible?
Neo4j, Titan.
Any
most of the graph databases are like supposed to be built on Tinkerpop.
So you use this for your CRUD operations?
Yes. So the Gremlin is like you can compare it with SQL if you are comparing with RDBMSs. So Gremlin is the console that lets you do the query and everything. So and Tinkerpop, you can say it is it provides you driver like JDBC in RDBMSs. So Tinkerpop is like it has a component, you call it as blueprints. So it is the basic component on which all the other components of the Tinkerpop stack are built. So that blueprint itself is acting like a driver for graph databases. So management APIs and database layer, like TX stands for transaction object, data management and optimizer. These are all internal to Titan, and they are all responsible for all the great work that Titan does. Like the transaction object is the one that is providing you the thread safety on different concurrent transactions.
So if I don't use the external index backends,
external index.
If I don't use that, right? So it is going to be slow on full text search kind of things.
It will not provide you any full text search. The full text search is actually provided by external index packets. And yeah, it will slow you down because there are two kind of indexing done in Titan. The first one is the composite index that it makes on its own. So like there are basically three types. I'm sorry. So the first one is default. Any vertex, any edge that you create, it gets indexed by default. Another one is like composite index, that you are telling Titan to index these vertices on the basis of these properties. I will be giving you these properties, you will be returning me these vertices. So you are making a composite index. Third one is a mixed index. And the mixed index is something that you are using the power of external index backends. So in a mixed index, if you are creating a mixed index, then that index will be stored in your Elasticsearch or UC. So from there you can use the full text search and others. So future of TitanDB is the TitanDB is an open source graph database that is being provided by Aurelius LLC company, which is a startup company, and it made a huge improvement on the graph databases, and it provides most of the support to the Tinkerpop stack. So the Tinkerpop stack, I already said, that works with most of the graph databases out there. So it has huge contribution to the Tinkerpop stack. And DataStax is the company that delivers Apache Cassandra. It was also a startup, but had better experience and better resources than Aurelius. So DataStax and Aurelius got merged on February 3rd, 2015, and they started working on a separate database that is called DataStax Enterprise Graph Database. So it will be using Cassandra data store with the Titan database, or you can say that Titan-like properties will be there, because they are improving it. They are saying that we will still be having Titan as open source, but there will be a separate graph database that will be coming out soon, that is called DataStax Enterprise from DataStax, and which is being made by DataStax and Aurelius in collaboration, and it will be much better than Titan itself. So we have seen the power of Titan in many cases, and we think that this new database will be a competitor to Neo4j. That's it. In this DataStax enterprise graph, the main emphasis will be on Cassandra. So backend storage will be Cassandra, that is fixed. Okay, so what is Apache Tinkerpop? So graph processing system currently under Apache incubation, it is being developed and continuously being under development since last year. So Tinkerpop has provides you the graph computing using two things. First is a structure and the other one is the process. Here structure is referred to your graph that contains your vertex, edges and properties. Process refers to the traversal and other methods that you use to get the data out of your graph. So the Tinkerpop 3 structure API has the graph element and property. So here element has the vertices and edges, and like I already mentioned, and process API has the traversal source and the graph computer. So what is a traversal source? It provides you the traversal object on your graph. So this is the one responsible for providing you a better way for queries. So whenever you have a raw graph, you will need to create a traversal object out of it, and then you can go through the huge number of edges and vertices in a single go. Like you can say that give me an edge that is being taken out from this particular vertex with an ID this, and get me to this particular vertex. So that is something. Graph computer, as I already mentioned, is a system that works on every graph vertex separately in concurrent manner and provides you with high concurrency. Gremlin query language, as I already mentioned, is a scripting language for graph traversal and mutation. So Gremlin is something that provides you console to interact with your graph, and it's more or less equivalent to your SQL console. So REST API. So initially, Titan was having Rexture as the REST API. So it provides you a doghouse console from which you can use the HTTP methods like get, post, and put to use, create, and get your and fetch your data from the graph. So nowadays the new versions are providing you Gremlin server, which has a similar capability, but there is a difference. Like the Rexture was also able to make the visualization of the graph. So the older versions of Titan provide native support for visualization, for which nowadays we have to go and depend on some external API or some external JavaScript method. So the earlier versions were having native support for visualization. As soon as you enter any vertex or any edge, you can connect Rexture with a streaming API, and it immediately reflects that back on your browser. So if you are like having on one screen having your console, Gremlin console, and you are typing in commands for creating vertices and edges, and there is another screen that is having the browser that is connected to your graph, then you can, as soon as there is a vertex created, you can visualize it on your browser. And also it provides you a visualization of the traversals. So if you are providing a query that I need to traverse from this particular vertex to another vertex, so it will be highlighted in your Rexture console as well. So Jiffy does the same thing, and Jiffy is open source, but it has some compatibility issues, and we are also trying to use it. The latest version is 0.9.1, which is not currently working with the latest version of Titan. So we are having trouble with the new and the latest improved version of Titan, because
the current version of Titan 0.9?
No, the current version of Jiffy is 0.9.1. The current version of Titan is 1.0.0, which is stable, but there is another version 1.1.0 snapshot which is being developed.
And Tinkerpop is just one of the ways to work with the graph database, but TitanDB provides something of its own, or do we always have to use Tinkerpop?
You always have to use Tinkerpop. Tinkerpop is natively provided by TitanDB.
Question. A lot of the low-level operations are supported by Tinkerpop, like create node, get vertex, walk the graph. What about higher-level operations like subgraph analysis, vertex density, small world stuff? Any of that supported?
Yes, you can use the partition functionality from that is also given in your Titan graph. So you can partition the graphs in various formats. Like you have a huge graph, but you can partition it in segments or fragments, and you can operate on those partitions separately. But it is very complex, and it's not really a piece of cake for someone like me who is just introduced to Titan. So yeah, it has complex operations like
It's like vertex density would have how many other vertices are connected to it?
Yeah, so small world properties of a graph, like this is something I did a lot of graph theory when I was in grad school, and so when you look at graphs from a large scale perspective, it's important to know all the little sub features that are inside of it. When you sort of characterize a graph, you can look at it in terms of these metrics like vertex density or small world
they are
properties.
the degrees. They are
Degrees of, yeah, exactly.
So in degree and the out degree of a vertex, like how many edges are going through and how many edges are coming in. So yes, that is like something which Titan also provides, and you can have metrics in your test cases as well for performance. So that is how they are also having the, like I already mentioned, the source supernode problem.
Mm-hmm.
So that is something that they come through and saw that there is a problem with our metrics. We are already getting this metrics that we are not going to get the data in time if we are keeping this up. So they introduced the concept of vertex-centric indices.
And things like aggregation, say for example, I've got friends and friends have got friends and so on.
Yes, so
what
it
is
also provides you the map to use that. So Titan does all that natively using TitanDB.
Okay, but do I have to write my own MapReduce job for that? Like I remember in React we were writing our MapReduce jobs and okay, now
I'm not so sure, but as far as I have used Titan, I haven't
But then you will get aggregations with Tinkerpop.
Yeah, it's like it provides you multiple methods which are combined together and gets you the same result like a map and a reduce. So I haven't used my custom built map reduce methods until now. Okay, so need for Apache Tinkerpop, dealing with complex databases as the graph databases are. It requires a well-implemented API by the vendor. If you are using a Neo4j, then you need an API from Neo4j for the proper handling of the graph database that they are providing. Or if you are using a TitanDB, then there must be an API that fully utilizes all the features of Titan and gives you the real power that it holds. But that would be creating another problem that you cannot migrate to another database if you want to, and it will be impossible to get the cache from the vendor. So in that case, they decided since it is open source and Tinkerpop is also open source, so they decided to have the native support for Tinkerpop, and most of the graph databases supports Tinkerpop, so you can use flawlessly any of the databases that you have. So you do not need to change any of your code because the API is same. So let's go with the demo. I think here. So I have a dummy application that uses the CRUD operations on Titan database, and it uses Cassandra data store backend, and it does not have any secondary or index storage right now, and so I have no indexes built in as of now, and also it is not required because I am storing very little of data, so only 2 vertices and 1 edge that can just let you see that how we can create vertices, how we can create edges between the two, how the labels and everything we can edit, and how we can fetch. So if I am just running the test cases, I have a tier down process, so every time the test case finishes, it will delete the vertices or the edges that is being created in the data storage. So from here you can see that these IDs are something that been created by Titan itself. We are not mentioning any IDs. So label, I had 2 persons. Label is you can say that it is a type of vertex. So I have 2 vertices, type label, type person, and I have an edge between them, and edge label is friends.
So the IDs are so different for the group version. So the ID for
yes. Actually, I think I might have used the same ID twice, maybe in code. So
no, what I meant was that one is
yeah.
8 digits and another one is
Let me just check it. Nope, that is generated by a database, so I don't know how.
Probably have many more edges than you would nodes, so use a GUID for edges because that gives you more space for.
Yeah, could be because I was running the test case again and again and again, so I don't know how it is doing that, but it randomly generates the ID. And it keeps tracks of the IDs. So
But we can, like, I think what Jason is saying, that we can custom
Yeah,
generate the IDs, like if you want to
Yes.
do it there.
yes, if you write the logic on your own to provide ID, then it can use your own IDs.
And since the edges are going to be much more, then we will do it for edges.
Yeah, exactly.
But I suppose that if we are using
Yeah, that's what that looks like.
if we are using huge graphs, then it's not really a good practice to give your own IDs because after a point of time there could be a case that hashing performs in Titan, so they optimize their own IDs and they does it internally so that your vertices are like stored properly.
And when it says you're querying, iterating all the vertices, it's almost like a full table scan in
Yes.
RDMS, and then
So it is a default message. Even if you have two vertices, it will still say that there could be possible degradation in your performance. So because you are not using any indexes and you are just iterating over all of your vertices.
Which is pretty much like a full table scan that we are doing.
Yes, yes, and it actually says so because it is built for a huge graph. So like it assumes that if you are using Titan database, then you are going to put a lot of vertices.
do you know what there is this is probably way something I wouldn't even know. Is it the indexing mechanism they're using, like a traditional, say, like binary index or B-tree index on a database? Are they using something similar, or are they using something completely different? Do you know?
I'm not so sure, but I think that it is B2.
B-tree.
I need to go and check it out once more, but I think probably it's B2. So that's all from my side. So that's all in this.